The thermodynamic process is shown in the figure. The thermodynamic process is shown in the figure. Okay. Now take this problem. A thermodynamic process is shown in the figure. A thermodynamic process is shown in the figure. Full stop. The pressure and volumes corresponding to corresponding to some points in the figure are PA, pressure at PA is equal to 3 into 10 to the power of 4 Pascal. PB is equal to 8 into 10 to the power of 4 Pascal. PA is equal to 2 into 10 to the power of minus 3 meter cube. BB BD is equal to 5 into 10 to the power of minus 3 meter cube. Full stop. In process AB, AB 600 joule of heat is added. Heat is added to the system. And in process BC 200 joule of heat is added. Full stop. The change in internal energy of the system. In process AC is. AC would be. So they are given this one. So I'll read the diagram also they are given. Just to see the process diagram. They are given, not my diagram. So this is the volume. This is the pressure. This is the shape of it. Very easy, nothing is there. AB, BC, DC, arrow. This is JB. Like this. Okay. So the volume is constant, whatever will be the pressure over. So the volume is constant, whatever will be the flow. When volume is changing, pressure is high, what can be there? So what is the area of this for AB area? Line point, not constant. So For the work done AB, so what is given? 612. Work done, it is given WAB is given 600. Okay, but W, the regard what is meaning to the inner length. So WAB is equal to 0, but WBC is given, this is the what is called WBC is how much is given? 200. 200 joule. Once again, no. WAB is equal to how much? It is 0. But WBC is given as, what is the given WBC? WBC 200 joule is given. 200 joule is given. Wait, correct. The work is 0. What is the WBC? WBC is equal to, wait, WBC is equal to, what is the area under this one? Pressure is constant. What is the pressure? PBC or PBC, both are same. PB, whatever PB is there, PC other. What is PA there? PD also there. Same pressure, they are constant pressure. Pressure into difference in volume. Difference in volume. So volumes are given. What is the volume at B? The volume at B is equal to 5 this. Volume at D, how much? 5. So the volume at C is same. Volume at A is the volume. What is the volume? It's the same volume here. But now volume at BC, what about BC? What is the VA is given? VB same. What is this? 5 minus. This is VC minus VB. There is no not understanding question is not there. This is the volume. This point the volume point. VA is equal to VB volume wise. VB is equal to VC volume wise. But pressure PB is equal to PC. Pressure PA is equal to PD. Constant pressure. Because constant volume here is constant. Volume is constant. Understood? But now what is there? WBC is equal to work done in process BC is equal to pressure into volume difference. The pressure at PA or pressure at PD both are same only. So the volume difference, what is the volume? B, which is the final volume, the final volume. Final volume minus initial volume. So that's why it's equal. Now can substitute this value, how much you are going to get? This pressure 3 into, if you PB is good. PB, PA. Oh, sorry. These are PB value how much? 8 into 10 to the power of 4. 5 minus 2. DD minus 2 into 10 to the power of minus 3. Simplify how much you are going to get? The work done BC. Only 1.8 what is the value? 5 minus 2, 3. 3 8 is 24. 10 to the power of 4 into 10 to the power of minus 3. How much? 10 to the power of 4 into 10 to the power of minus 3. How much? 10. Just that much. So is the work done here. Now, I want to find the AC work done. This work done AC is equal to sum of VAD, not VAD, WAD work done to AD, work done to AC is equal to WAD plus WBC. Okay. Or you can write WAC is nothing but this also can take WAB plus WBC, nothing but now. So now in this case, this WAB is given 600. WAB is given how much? 600. WBC. So WAC is equal to how much? 0. This formula is 0. So WAC is equal to WAB is equal to 0. WBC just now we got our organized is 240, right? That is equal to 240. You see here, this is a path. This is the work done is 0. 0. So 240. Okay. Next, we go for energies. Big energy. QAC is equal to QAB. QAC is equal to QAB plus QBC. The QAB energy is given. Heat added. This is the work done. Heat added. Heat added is not 600, but BC is 200. They are given heat added. So that is equal to 800 joule. So now according to the first law, 5-6 will come finally. According to the first law of thermodynamics, first law of thermodynamics. So QAC is equal to internal energy DUAC plus work done DWAC. This I got 800 is equal to AC is given 1.8 DUAC plus work done to WAC is equal to 2.0. Wow. Now we subtract it, you will get inner energy. The difference is inner energy. So much our getting energy. So CUAC is equal to 800 minus 240. Okay, now should how much you are getting? 560. 560. Now, once again, read the problem by yourself. You can try to understand. Now, what is it going to say that? You see here, thermodynamic process is shown in the figure. The pressure and volume corresponding to some points. So, they are given here. The pressure is the same pressure. So, PA and PB. So, pressure is this point is PA. PB. Pressures are different, but volumes are same. PA is given means PB are the same. Here the pressure is given means what? This pressure is different. Here the volume PB means each are the same. So now PA is given and PB are given. Rather PA, PB same thing, PB same thing. Right? And volumes are given. PA is given means PB are the same and PB is the same. Right? So in this process AB. In the process of AB, 600 joule of heat is added. 600 joule of heat is added. I have written work done, this is wrong. So heat added. Then what I have to write? I have to write QAB. This small mistake there is QAB 600 joule of heat is added to the system, and then in this process BC 200 heat. So this is not the work done. This is the heat is added. Here is. That's why I need this small. So now this 2 Heat is added. How much added is QBC is equal to 200. Slowly added. Okay. Now that the change in internal energy, they're asking you, what you got to say? B changing. BU. B. What is the internal energy? Changing internal energy of the system in process AC. So process AC. Now we like AC process. So AC process we can go with the AD and the DC. AC process can go with the AB and DC. Whatever it is. So what is this looking like? It is looking like what? Okay, square only. What a square dimension. So right. Now, but QAC the what is the work done here? Work done to AB 0. Work done to DC there. Therefore, work done to AC is equal to work done to A. It's also like now I have all the known values are the rectangle. Work done to AB plus work done to BC. There is 240 we got it. Now, the heat supply to the system QAC is equal to QAB plus QBC. That is what total it is 800. Right? Now, our current first law what are you? QAC is equal to internal energy plus work done AC. What is internal energy? What is the heat supplied? 800. Or we added this 800 plus PUAC plus 240. What we have already? Right, go to the. So, right, isothermal process. Come, Athona.
And then PV value.
PV different one.
PA and 3 into 10.
The work done to BC I want to find. Work done to BC is equal to PA value. PV PV is the BC number. Yeah. So PV into BC minus not PV. PA is 3. This is not a PV today. So what is calculation? In the energy model, what I did mistake is work done is joule is joule. Unit is joule, but application is different. So we go to unit by that. Right. Isothermal process is our. Sorry, I will show that. So there is a diagram, but easy diagram is not a complicated. But further will be more important. Right. Isothermal process. Underline please. It is a slow process. It is a slow process by keeping temperature constant. By keeping temperature constant. By keeping temperature constant. Now all of them there is nothing but Boyle's law. So the work done in isothermal process is W is equal to integral V1 to V2 PdV. But as we know that PV is equal to what? nRT. So I have to make this in terms of what we call V, because then only it is possible to integrate it. So W is equal to integral V1 to V2. So in place of P is equal to what? nRT by V. So I can write nRT by V dV, which is constant capital dV. These are constant. Number of moles, universal gas constant, and absolute temperature constant. So for that, what I can write? Integral V1 to V2. I can take nRT out. So 1 by V dV. Very simple. We don't want much integration. integral 1 by x dx is equal to log x. The log x. So the base you should take one. I will take that is nRT into log b to the other e. So b1 to b. Apply the limits. Log b. Okay, so therefore nRT into log b2 minus b1. b2 minus log b1. So, if you know small logarithm is log AB to the base ER is equal to log A minus log B. So now we can write this is a small logarithm. So we can write nRT into log V2 by V1 to the base E. So if you take a natural logarithm, W. So now we can write it as this is a 2-point. So once you know the pressure and volumes are inversely proportional. So that's why in terms of pressure is given by nRT into log V2 place I can put P1, V1 place I can put P. Easy. Inversely means number is 1 becomes 2, 2 becomes 1. So therefore W is equal to natural log is given by 2.3 nRT into log V2 by V1 results. Copy this. Right. Compare it. So logarithm, last 10th class what logarithm? CBS problem. 10th class logarithm. Again, all of you. Okay, Nana? Now, right. Now, this what you call isothermal process applications. Just put that in applications, whatever, very obvious. Applications. That one. Specific heat. Specific heat. The specific heat is in case of the isothermal process. What is the formula of S? S is equal to Q by M delta T. In isothermal process, temperature is constant. Temperature is constant. This becomes 0. Then what is specific value? Infinity. Anything by 0, what the value? Infinity. Right. Infinity. So last two, isothermal process heat is equal to what value? That is the most important. Next. Isothermal elasticity. Isothermal elasticity. But I am keeping temperature constant. For the elastic value. Isothermal elasticity. Elasticity symbol is This is the temperature, T temperature. Isothermal elasticity. Because thermal means temperature required. E is the elasticity. Isothermal is temperature. That's all. Isothermal elasticity, how much we are going to get. So we know that what the equation PV is equal to nRT or a constant. We have to differentiate on both sides by differentiating on both sides. On both sides. So this is a constant. Some pressure is varying and volume is varying. So that is what DU method. DU differentiation of UV product method. First one you have to keep constant and keeping pressure constant and changing the volume plus volume constant changing the pressure. So when you become a zero. Now next one take PdV work done PdV is equal to minus V dV. The small mathematical. So therefore, I can say the bulk modulus or elasticity. There is a bulk modulus. So bulk modulus or elasticity is given by dP by. Now you bring this is the dP by dP divided by dP divided by dV minus dV by V. So, but change in pressure by whatever dV by V. So now I will take this fellow here. So what I will say, we need a change in pressure by dV by V. So dV by dV by L. Therefore, elasticity is equal to dV by change in pressure by change in volume. Elastic, what do you call? Volumetric strain. What is the volume? Are you understood?
P
P is the pressure. Pressure constant, volume change. Volume value pressure change. So that also elasticity is equal. E is equal to change in pressure. Change in pressure to V by change in volume. What volume? Volumetric strain. What is the volumetric strain value? dV by this one. So from here, dV, we want change in pressure, dP by the volume will what? Change in volume by original volume. Because elasticity. From this I am taking. This pressure I am not using. This pressure I am not using. So we will get a confusion what is the pressure of this. So this pressure we are not using. So therefore, what is what? Elasticity, thermal elasticity. Thermal is temperature. So here is pressure is changing and volumetric strain. Volumetric, what is the meaning of volumetric strain? Volumetric strain. Now you take a, this is the volume of the balloon. I am applying the pressure. Pressure slowly changing. What will happen? Volume is, this is the initial volume. Volume increases or decreases? Volume increasing or decreasing? Decreases. This is the final volume. Okay. So this final volume I can say V dash. Final volume minus initial volume. Initial volume more than final volume. So that's a minus we are writing minus. In bulk modulus. Otherwise it's a volumetric strain. Right? Now, but what about this fellow P? P is there. So P is equal to, that is finally that is equal to P. Look here. That is equal to P only. That is equal to P. So what is this fellow? This is becomes, please see here. I am not using P, but P that is equal to P. This is becomes what? Bulk modulus. Or bulk modulus I am writing thermal elasticity. So I am writing E theta. That means E theta is equal to P. That means thermal elasticity is directly proportional to E. So that is E theta is directly proportional to this constant. Understood that? So I will take this fellow to this side, dV, and cut it and bring it to top better. So that means what is thermal elasticity or thermal bulk modulus. So thermal elasticity is equal to pressure, right? So finally we need what? E theta is equal to P or E theta is equal to P. It is a better E theta is equal to P because one should have a direct proportion. No problem. Okay. So thermal elasticity is directly proportional to pressure. Please copy. Thermal elasticity is directly proportional to pressure. Please copy. Next. Thermal elasticity is directly proportional to pressure. Next course completed. Understood? Clear now? So an objective they will ask you, so related with the heat and thermal elasticity or bulk elasticity, whatever elasticity is, variable pressure difference. Pressure. Direct. More pressure, more heat. As you are applying pressure, heat is going to develop. As you are going to apply pressure. When the volume is increasing, temperature increases or decreases? Temperature remains, it won't change, decreasing. Generally, if you go to the volume relation with the temperature, more volume, less temperature. So, see that this is a room, small room is there. I am applying the fan. So, this much heat. When the volume of the room increases, it becomes a cooler. It's going to spread the same heat separate. That's right. The general way of thinking of that, nothing is there. Now, take another application. At NTP, at NTP, what is the meaning of NTP? What is NTP meaning? Normal temperature and pressure. STP, standard temperature pressure. Standard temperature pressure, both are similar. At NTP, isothermal elasticity is equal to, please write, at NTP, isothermal elasticity is equal to 1.01 into 10 to the power of 5 Pascal. At NTP, isothermal elasticity is equal to atmospheric pressure, otherwise that is equal to atmospheric pressure. That is value this one. Next. Now, next third application. So, what is the dq? First of all, dq is equal to du plus dw. But the temperature is constant. When the temperature is constant, this fellow du becomes 0. du 0. Therefore, dq, this is 0. dq is equal to work done dw. So, how you got? What is the du? NCV dt or delta T. But temperature, this is 0. What is this work done W? PdV. I don't want temperature here. PV is good, NRT is there. But I am not, but temperature, pressure into what I am taking. Now I don't want to bother temperature. But here, internal energy is equal to NCV dt, temperature required. But temperature is 0. Then finally, dq is equal to work done. dq is equal to work done. Okay. Right. dq is equal to work done. dq is equal to, right, ma. Take a small problem. Right. 1 mole of O2 gas, 1 mole of O2 gas having a volume 22.4 liter at 0 degree centigrade, 22.4 liter at 0 degree centigrade, and one atom, ATM, small ATM, one atom. What is the meaning of one atom? Atmospheric pressure. One atom is compressed. One atom is compressed isothermally so that its volume reduces to 11.2 liter. 11.2 liter. Please stop. The work done in this process is. So this is a V2, that is a V1. V1 is equal to 22.4 LIT. The temperature, you have to go to the temperature is now, what is the T? Temperature is constant, no? Temperature is constant, 0 degree centigrade. So T is equal to 270. I will write in 273 only. There you are, Kelvin. 0 degree centigrade means what? 273 plus 0, that is equal to 273 Kelvin. That's it. So already you know the work done formula. W is equal to nRT into log V2 by V1 to the base 10, 2.3 Now substitute it. 2.3, number of moles is 2. 1 mole, sorry. Number of moles is 1. R value 8.3 standard value into 273 into log. What is the V2 Nana? 11.2. Final volume minus initial volume. Final volume minus initial volume. What is that? 22.4. Now 11 1 ja 11 2. This is 2 to the base 10. So 1 by 2. So log 1 by 2, you have to find it first. Everything is fine. So log 1 by 2 case, log 1 to the base 10 minus log 2 to the base 10. This remaining you can get the value of this one. All of you understanding? So log 1 value, logarithm values, log 1 to the base 10 is 0. Okay sir, I will give the log value is 0 minus log 2 to the base 10 is how much? 0.3 you can take. So multiply, put this value. All of please multiply this one. What is that? Into 0.3 is enough. 1 decimal point is enough. I will give the log values. Please keep it in one place. But examination they won't give log table. So that's why you have to do it. Vibhushna understanding? Vibhushna? Right, Nana. I will give the logarithm values which are going to use it in our thermodynamics and other places in our entire physics. So there is enough, no need to go to light. Like I said initially, square root values, like same as rises. Log 1 to the base 10 is equal to 0. Next 2, log 2 to the base 10 is equal to 0.3010. Next, log 3 to the base 10 is equal to 0.4771, and log 4 to the base 10 is equal to 0.60205. log 5 to the base 10 is equal to 0.6989, and sixth one, log 6 to the base 10 is equal to 0.77817. Log 7 to the base 10 is equal to 8451. Next, 8. Log 8 to the base 10 is equal to 0.90309. Log 9 to the base 10 is equal to, this also go to 9, nearest to the one, 0.9542. And log 10 to the base 10 is equal to how much? 1. So what you remember is 1.0. By observing this, what you are going to do? Now this is a log 2 0.3, 0.4. You cannot able to rise because even number. You want to go to round up to one decimal point, one decimal digit. So this is a even number is there, not possible to rise 5 rather. It not become a 5. 0. It is not become 0. It is not a 0.5, 0.4 only. So log 4 is equal to 0.6. Log 5 is equal to, it is not 0.7, it is not, because it is even number as per rule if you are going to apply. As per rule you are applying, once you are going to round out to one decimal point, one decimal digit, there is a even number is there, but you cannot able to rise as per rule. So log 4 0.6, log 5 because of, or you can say 0.7, no, as per general mathematics 0.7, but it is not possible. Log 6 is equal to 0.7, but it is number is the odd number. You can write 0. I will tell you. So please, this is equal to approximately 0.8. So you cannot change as per rule, 6 only. So this is a 6 only. So this is a 4 only. This is a 3 only. Point. I am calling about 0. Don't say this one. So don't come much difference. This is the 8 is there. So this is you can take 8. This is you can take 9. This also can take 9. No problem. You put 1. So y means even number is there, you cannot able to increase. Rounding of numbers, rule is there, but general people are doing that. So it won't come much different. Even though you are going to do, it won't change the value. So this you have to remember this value. Like root 1, root 2, root 3, root 16, no, that more useful, more useful. Okay, thank you. Tomorrow we'll continue. Which one? Value. Okay. How much you got finally? This is one. Negative will come. According to negative one. Negative one. Right. Negative only. Correct only. What is the, after simplifying, how much value you got it? So 1,500 minus 1,572. I got this value. Still 0.5. Okay. Work done on the system is negative in physics. Chemistry, work done on the system is positive. The small difference also. So you may have chemistry also, thermodynamics there. In physics, work done on the system is negative, work done by the system is positive. That is a small difference, physics to chemistry. So they assume like this, we assume this one, both are. So negative means what? The work done on the system. The work done on the system. Okay, Nana, we'll see tomorrow again, same time by 5:30. Understood, Amma? Right, thank you. All of you understood?